All right, today we looked at how to come up with the inverse of an exponential or a logarithmic function. Okay, this is on, let's see, we're on page 9 of the packet. This is the last part of section 6.4. Okay, if you recall first semester, we've talked about how to come up with an inverse. If I had given you an equation like, say, y equals 2x plus 1. In the first semester, we looked at how to find the inverse of that equation. And think about that. What were the steps for finding the inverse of that? Okay, well, the first step was to flip where x and y are located. So we flipped. We put the x equals 2y plus 1. So the first thing we did is we just flip-flopped where x and y were. And then what do? Well, we solved the equation for y. So how would I isolate and get y by itself? I would subtract 1 from both sides. X minus 1 equals 2y. And then we would divide by 2. So x minus 1 divided by 2, that equation is the inverse of the original. So if we were to put both of those on a graph and put in our diagonal line of reflection, they would be mirrors of each other. Okay, now we're going to do the same thing with our exponential forms and our log forms. Okay, so it says write the equation of the inverse. So I'm going to do the same thing. I'm going to flip-flop where the x and the y are at. So I'm going to write this as x equals 10 raised to the y plus 1. Okay, now we have to solve for y. And where is y located in the problem? Well, y is in the exponent place. So what do I need to do to get that out of the exponent so that I can isolate it? Okay, you're right. We have to take the log of both sides, just like we did previously when we were solving. Since it's a base 10, I'm going to use the common log. So I'm going to take log of both sides of the equation. Okay, since this is a base 10, these undo each other, and you're just left with y plus 1. Over here, we can't do anything with the log of x. Okay, and then how do I get y by itself? Okay, well, I've got to subtract 1 from both sides. So I've got the log of x minus 1 equals y. This is the inverse function of the original. Notice that the original was an exponential form, okay, the original, and the inverse is a log form. And when we graphed that on our graph, we showed you how the log and the exponential form were actually kind of mirrors of each other, right? They were inverses of each other. That's the way that they graphed. So that's what I expect to happen there. Okay, let's go down. Let's pop down to C next. Okay, now this is in function notation versus not having a y. So all you need to do is replace the function notation. Say 3 raised to the x plus 2. So nothing has changed. It's just in function notation. So we're going to put the y back in. Now we do the same thing. We're going to flip-flop the x and the y. Okay, and then y is now in the exponent spot. So what do I do to both sides of the equation in order to get y out of that exponent? Okay, we're going to take the log of both sides. Now this time we can't use the common log because this isn't base 10. This is base 3. So I've got to take the log base 3 of both sides of the equation. Okay, when I do that, this log base 3 of 3, that's going to cancel out. You're just going to have y plus 2. Over on the other side, we can't evaluate anything there. That's just log base 3 of x. And what's my last step to get y by itself? I need to subtract 2. Okay, so I'm going to say y equals, I would have that log base 3 of x and then minus 2. And that's my inverse equation or my inverse function of the original. All right, now this one over here, b, okay, this is not in exponential form. This is in log form. I still follow the same steps. I'm going to flip where x and y are at in the problem. So I'm going to say x equals log base 7 of y plus 5. First step is always to flip where the x and the y are at. Now, to solve it, it's in log form, so I'm going to put it into exponential form. Okay, I'm going to say 7 raised to the power, here's log base 7, so 7 is the base, here's your exponent, and that's equal to the y plus 5. The parentheses are no longer needed. Okay, I'm going to subtract 5 from both sides. I'm trying to isolate y. So 7 raised to the x minus 5 equals y. You've got y by itself, so that is, you're done. That's the inverse equation of the original. Notice that the original was in a log form. Your answer's in exponential form. Okay, and then the one bottom here, again, if it's in function notation, textbook a lot of times wants to put it in function notation. Just no big deal for us. We're just going to substitute a y. Okay, we'll substitute the y and then we'll follow our steps. We'll flip where x and y are located. Okay, now this time I can't go into exponential form yet until I have the log isolated. I don't have the log part isolated yet, so I've got to add 2 to both sides. So I've got x plus 2 equals log base 7 of y. Okay, now I can take it out of log form and I can write that exponential form. It's log base 7, so it's 7. This is all the exponent. X plus 2 is equal to y. We've got y by itself. This is the inverse of that equation. Okay? If you have any questions, shoot me an email. Give the worksheet a shot.